Good day students, welcome to Practical 3. Today we'll be investigating solubility and stoichiometry. Experiment 1 will delve into the solubility of potassium nitrate, followed by experiment 2, which will visually represent a precipitation reaction due to the difference in stoichiometry. For experiment 1, we're going to make a potassium nitrate solution by adding a specific mass of potassium nitrate crystals into water, making sure it dissolves totally, followed by recrystallization in an ice bath. We will then filter the crystals so that we can weigh the mass that crystallized out of solution. Now that the potassium nitrate solution is ready, we are preparing an ice bath for recrystallization. Fill the beaker halfway with ice and add water to make sure that the beaker containing the potassium nitrate solution is in contact with the ice cold water. Make sure that the meniscus of the potassium nitrate solution is beneath that of the cold water. Once this is done, we need to measure the temperature of the solution as recrystallization is initiated at this point. The temperature needs to be stable for about 10 seconds. Once the solution is placed in the ice bath, it needs to be left undisturbed for about 10 minutes to ensure that the crystals can form evenly. Now that the crystals have recrystallized and the Buchner funnel has been set up, we can open the vacuum and place a few drops of distilled water on the Wattmann filter paper. This is done to ensure that the Wattmann filter paper is not torn to shreds once the crystals are added to the filter paper and we lose our crystals. Now that the filtration is done, we can remove the filter paper from the Buchner funnel and transfer the crystals to the watch glass so that we can weigh the recrystallized mass. The topic of experiment 2 is stoichiometry. In this experiment, we will perform a precipitation reaction by adding known volumes of lead nitrate and potassium iodide. Add the appropriate volumes of lead nitrate into the vials using a clean syringe. Using a clean syringe, we will now add the appropriate volumes of potassium iodide to each vial to make up a total volume of 3 cubic centimeters. Once all of the vials have been made up to 3 cubic centimeters, we need to swirl all of them to make sure that all of the lead, nitrate, potassium and iodide ions can react with one another. Once swirled, the vials need to be left to stand so that the precipitation can settle at the bottom of the vial, as we need to measure the height of the precipitate in every vial. When measuring the height of the precipitate, make sure that the line, which is aligned with 0, is at the bottom of the vial and not the bottom of the ruler, seeing as the measurements only start about 5 millimeters above the end of the ruler. Remember that the insoluble lead iodide precipitate that formed is toxic and needs to be disposed of in lead waste. To get the precipitate into solution so that it can be decanted into the waste disposal, we simply shake it so that the precipitate is suspended in solution, after which we decant it into the container. The lead iodide that is left in the vial must be wiped out with a tissue paper, which should be disposed of in solid waste containers. Now that we have captured all of the data for Practical 3, you have enough information to complete your practical report successfully.